we start with the next question. Compute a raised to power 9 minus 6 a raised to power 8 plus 10 a raised to power 7 minus 3 a raised to power 6 plus a plus I, where a is given to me. Okay, so what we are going to do is we are going to again start and do the basic thing. I am going to be defining the characteristic matrix and then the characteristic polynomial. After that is done, we will find the eigen values as well. So the characteristic matrix will be a minus the lambda I minus lambda 2 3 minus 1 3 minus lambda 1 1 0 2 minus lambda. Okay, so then we go ahead and we define the characteristic polynomial. The characteristic polynomial is mod of a minus lambda I, which is also like lambda cube minus trace of a into lambda square plus SMD of lambda minus determinant of a. So we go ahead and we find the trace will be equal to 1 plus 3 plus 2, which is 6. Then we go and we find SMD will be equal to
102 plus 1312 plus 12 minus 1 3. So which will give us 6 plus 2 minus 3 plus 3 plus minus 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 plus 2. So this gives us 10.
Then we go ahead and we find determinant of a.
Determinant of a will be equal to 1 into 3102 minus 2 into minus 1112 plus 3 into minus 1310. So this will give us 1 into 6 minus 2 into minus 2 minus 1 plus 3 into minus 3. This will give us 6 minus minus plus 6 minus 9. 6 plus 6 is 12 minus 9 will give us a 3.
So now we have all of the values required, so we can go ahead and define the characteristic equation. So we write here the characteristic equation, which is defined as a minus lambda I in mods is equal to 0, will be given as lambda cube minus 6 lambda square plus 10 lambda minus 3 equals 0. I am going to be using Cayley-Hamilton's theorem. So by Cayley-Hamilton's theorem, we know what it means. It says every square matrix satisfies itself, or we can write satisfies its characteristic equation. So we will be writing here a cube minus 6a square plus 10a minus 3 is equal to 0. Now here the question is we have to compute this expression. So let me just copy paste this expression here.
So I don't know what went wrong with the audio, but basically I am dividing this equation by the the square matrix equation that we have gotten, and so basically everything gets cancelled out and we get the following quotient.
So now we know that we say dividend equals divisor into quotient plus remainder. So here this is the dividend, a raised to power 9 minus 6 a raised to power 8 plus 10 a raised to power 7 minus 3 a raised to power 6 plus a plus I, and our divisor is a cube minus 6a square plus 10a minus 3, and our quotient is going to be equal to a raised to power 6 plus our remainder is a plus I. Now this we have proved is equal to 0 from above, right? So let me just put this in a different colored box. So from here we know that this will be equal to 0 here. So this entire term becomes equal to 0. So we'll have the value of this equal to a plus I. Now a plus I will be equal to the given matrix plus the identity matrix. So we'll have the value as 2 2 3 minus 1 4 1 1 0 and 3. So now I'll just check if this is the solution. Yeah, that is this. So this is one of the main applications of our Cayley-Hamilton's theorem. It is a very comparatively this was a smaller example. There are bigger ones as well. So if it were to have a huge weightage, so they will also ask us to find the inverse, which can easily be done. We just have to multiply inverse of it on both of the sides. So here we'll have to add inverse, so it will something be like this. I'm not going to go ahead and solve the entire question, but it will be something of this sort. Minus 3a inverse equals 0. So here this becomes a square, and this will be 6a, this will be plus 10i, and this will be minus 3a inverse equals 0. So I'll just solve out everything. Okay, so a inverse becomes equal to all of this upon 3. Okay, so something like this can also be asked, and then you always obviously have to get like the value and not just leave it here, get the matrix value.
Okay, so I have tried my best to cover all of the concepts of Keller-Hamilton. This particular concept is very important when it comes to the chapter of matrices. So expect one question from it for sure, for sure. So yes, you can go back and watch the video again if you have any doubts, or else you can write it down in the comment section. I'll try to help you as much as possible. That is it. Bye bye.